All right, morning everyone. And let me hope that you can hear me. Are you able to hear very well? Good.
Yes, we can hear you.
Thank you. So this week we are going to make it a math. Ever since we started these tutorials, and I'm hopeful that we have gone miles. We are not the way we started, and I'm hopeful that people those ends you have started practicing writing scripts in and there, looking at scripts and understanding them. And those ones that have not started, let's start. Those ones that have been practicing each day that passes, we keep on improving in and there. So for the last time, something like 2 to 3 weeks, we also learned how to familiar ourselves with data that comes in Excel format. In this case, we are able to look at our observation data sets. And in this case, we looked at the July monthly decados for the month of July 2025. So, and we left with some bit of assignment. By the end of this class, we shall get to learn which are those groups that tried and which ones are able to present. Okay. So for today, we are going to learn how we can download data from the ECMWF and how do we get this data? How do we further analyze this data into maps, into graphs, so that we can use it in our operations? So we are all familiar with ECMWF, that is European Center for Medium Range Weather Forecasts. This is I doubt whether this is something that would be new to anybody here. This is a center that is found in Europe, and most of the products that we use, they actually come from them and the data sets that we use. So I've put up a few presentations that we are going to follow. And in case you have any questions, you can ask in and there. So what we need to do is you go to this website, this that I've shared. I'm going to share this presentation, just copy and paste this into your copy and paste this into your browser, and then it is going to take you to this page. And once you go into this page, it will prompt you to create an account. That account is free of charge. So open an account. And after opening this account, then you will go to, you are going to go to your profile. Then it is going to generate an ID for you. And it is this ID that you are going to use to be downloading the data sets. In case you get challenges, I don't know whether this could have limitations from where I would be, because my first attempt to download data sets, I was not in Uganda, I was in the Netherlands. So I was able to seamlessly gain access to data sets. And when I tried it back here in Uganda up to now, I've been able to use the same credentials. So you can as well try And in case you are facing challenges, then you can let us know. So after going through this, then you are going to go, you will click on datasets. And once you click on datasets here, then it is going to take you to this page. And with this page, you are going to browse through and you look for ER5, hourly data on a single level. And these data sets, they were back from 1940 to present. And here you can interface with it. So let me go to the browser now. So this is what we said we have, that once we click on data sets, then it has very many data sets. You are going to click on ER5, hourly data on a single level. All, once you use this link the way it is going to automatically get you here. And in this case, there are a number of variables. We have the reanalysis data sets, we have the ensemble mean, we have the ensemble members, then we have the ensemble spread. My point of interest here was on the reanalysis data sets. And in this case, we have a number of variables. Here, it is going to show you the most popular ones that people do download. You have the 10mm U component of wind. We have the 10mm V component of wind. We have the 2M dew point temperature. We have the 2M temperature. We have the mean sea level temperature. We have the mean wave direction. So there are a number of parameters. There are a number of parameters that you would download. Now, then here we have temperature and pressure. We have the 2mm dew point temperature. We have the 2mm temperature. We have the ice temperature. We have the ice temperature layer 2. We have the ice temperature layer 3. We have the ice temperature layer 4. We have the maximum 2M temperature since previous post-processing. We have the mean sea level temperature. We have the minimum 2M temperature since previous post-processing. So the most important thing here, you must understand what you are doing. You must have set up your problem, and then you come here when you really know what you are looking for. You know which kind of variables that you are looking for. In case you are not sure, then you need to go back and read, and you get to understand which kind of parameters that you are going to read for. Because if you don't, then there is no way you can download everything, because the kind of computational resources that you have, they may not allow. So it is very, very important for you to know what you are doing. So for my case, I was interested in the dew point temperature. I was interested in the surface temperature. I was also interested in the surface pressure. The rest, at a point in time, I was also interested in the 2M temperature. So those are only the variables that I was interested in, just depending on what you want. So whatever that you want, you are going to tick. So you are going to tick it. And once you tick it, then it is going to be part of the things that you are going to download. So you have the wind, you really know what you want. Are you interested in the 100mm U component of the wind, and V? I think this is the U is horizontal, this is the vertical component of the wind. So really you need to understand which kind of things that you are looking for. This is the mean rates. And this is the radiation and the heat. So you only select those things that you you are interested in, because we said if you don't, then downloading may need a lot of computational resources, which computational resources may not be, you may not have. This is something to do with the clouds, the cloud base height, the total cloud cover, the high cloud cover, the total column cloud ice. All those things are important as far as climate science is concerned. They are all very important. So depending on which kind of study that you are working on, then you are going to select the kind of variables that you want. This is evaporation and takeoff. This is precipitation. So for my case, I was still interested in the when it got to precipitation, I was much interested in a convective precipitation, because this is what I would use to get the convective adjective precipitation, which is the cap, which was very important as far as precipitation, total precipitation prediction is concerned. So here you may have, here we have the total precipitation type, and then we have the total precipitation. I was also interested in this, okay? And then the large scale precipitation, no. Still, I was also interested in the convective rain rate, because my area of interest was to really to look at those parameters that would help me define that would help me understand and define the causes, what could cause rainfall, the trend of rainfall, so that I can base on them to predict this total rainfall. For snow, still you can select. If you are not interested, we are in the tropics, we rarely get snow. It was not something that I was interested in. For soil temperature, I didn't look here, but in case you are interested, you can always look at those kind of parameters that you are interested in. There, as we can see, there are a lot of parameters. So after that, we said the datasets range from 1940 up to 2025. So it depends on how you want. To share with you my scenario, my first attempt was to download datasets for 31 years. So I went and ticked and ticked and ticked until when I went to 1993. I got a script that I'm going to share, and I thought that this would download the whole datasets at once. I waited for one day. The datasets wouldn't finish. And after that, the script crashed that the computer had run out of the computational resources that I would use. So I went out of that attempt. Then I decided to download datasets for 1 year per download, up to 31 years. And still, while downloading 111, I was only able to finish that after something like 4 days, when the computer is downloading non-stop. And I was only getting around 6 parameters. So in this case, you can select the month. Personally, I was interested in the whole months, so January to December. You can as well select the days. In my case, I was interested for the whole month, okay? And then you can select the time steps, the time that you want. Is it 00 up to 23? So depending on what you want. And after that, you can select your geographical location. In this case, for here, this is covering the whole globe. So in any case that you're interested, in my case, I was interested in Uganda as a country. But before going to this, I made these changes within my script that I'm going to open, that I've already shared with you people. So you can as well select the kind of latitudes that you want to download, because this is covering the whole globe, but only select those things that your region of interest. My region of interest was the boundaries for Uganda. So I selected the latitude and the latitudes and the longitudes that would capture Uganda boundaries. So after that, you are going to select the data format that you want to have your data sets in. In this case, I selected netcdf4, okay? And I also came here and said that if it's more than one file, you let the files be archived. After that, you must have logged in and accepted to the license. Then, depending on what you have selected, the script is going to write for you an API request like this that we have used to develop that would copy and then embed within your Python script. So you have to copy this and embed it within your Python script. So I'm going to share with you a script that's already embedding this, that has all these things embedded in. Okay. Yeah. Any questions so far? Do you have any question to ask before now we go into the actual downloading? Do you have any questions to ask before we go into the actual downloading? So are we able to see the script? Are we able to see the script, colleagues?
Yes, we can see.
All right. So the script that we have, this script puts together and it connects automatically to ECMWF and it is able to download. So from the API that was generated, we built a CD SAD client. This line of code helps us to connect. It connects our credentials that could allow us to connect directly to ECMWF. And the first line now, it redirects the directory within my computer where I'm going to download my datasets from. Okay. And then the dataset and the variables, here I defined the datasets and the variables that I want to download. And the dataset headers, it is reanalysis, ER5, single level datasets. And in this case, I'm picking only one variable, which is total precipitation. So the way the name it appears here, it would be the same way that it appears within here. So in this case, I'm only picking one. So I select the year I'm interested in. So whatever that I would have selected here, however much I've selected many years, I would come and change it from here. So in this case, I'm getting data for 1993. This one, you can change it to any years that you want, provided these years are within this block, within this range of years. So from 1940 to 2025. And then the month range, in this case, I was interested from the 1st, that is from January up to December. So I'm stopping at 13 and I put a comment here. Reason, once I say up to 12, then it is going to stop to November. So once I say up to 13, then it is going to stop at 12. So in this case, I'm able to get data sets from January up to December. So the time frame, I'm interested from 00 up to 23. So I'm capturing all those data sets from 00 up to 23 for each day on a daily basis. And this script loops over months. The for loop function is not something that is new. So for month, and I'm using the in operator. These are not new things. These are things that we looked at. So for month in months, that go and collect all months that have been selected here and join and generate files for each month, okay, into the output directory, which is here, and save the files as Uganda precipitation, the year, the month, and it is going to be a .nc file. And here is my request. The product type is reanalysis. The variables, this is a variable name that was declared here. So whatever that is being put here, the variables are going to be passed over into this. Who can tell us which data type is this? Which data type is this? Is it a list? Is it a dictionary? Is it a set? Or is it a tuple? Which data type has a keyword, a key value, and the value? Who can let us know?
I think it's a dictionary.
So that's a dictionary. So we have a key value, and then we are passing. So this is a key value, product type, and then the variables. The value is reanalysis. The key value is a variable. Then the variable values are what is being put here. Year. Then the value is what is the year that we declared, and the month that we declared, and the day. So we are passing on variables, and this is a dictionary. The time, the area. So the area here, and this is when we capture the north, the west, south, and east. This is when we capture the boundaries for Uganda. And then the format through which we should have our data sets, it is a netcdf. So here we are retrieving, and then here it starts downloading. So in this case, as you can see, when I ran this script, I was able to download these data sets. And once it finishes, then lastly, it has to bring for you this file. So I was able to download at each instance. It downloads the total monthly data sets for 1993 from January up to December. And ultimately, it is going to save. After saving everything, then it is going to bring for you the last statement that all months for 2025 downloads has been shared successfully. Okay, so this is one way through which we can download data sets. You can familiar with it, you can try on your own, and you get to understand how these things do work. So next, if you don't have any questions, there are cases when we want to download many parameters. Most of the things, they are the same, but what would change is just here. Here, the variables, I defined only one variable, but in this case, you are going to define the variables the way you want them, okay? In this case, I wanted the dew point temperature, the temperature, the surface temperature, the surface pressure, the total precipitation, this U component of the wind, the convective precipitation, and the large-scale precipitation. So who can tell us what is this? Who can tell us what this could be, this line of code? Who can volunteer? when we look at the DEF, what triggers our mind? When we see DEF, what triggers our mind?
It is a function to get the number of days, to get the days structured in a month and year.
Yes, so in this case, we are defining a function, and the function is called getDays, and we are passing on variables year and month. And then, in this case, year hint means that the year is going to be an integer. The month is still, it is going to be an integer. And the number of days here, I'm able to define the number of days. And then the return function, in this case, it is going to return for us the days in a range that is given from 1 up to the number of days that are being defined within this variable. So it is very important for us to get familiar on how to look at these things. When you look at the code, then you are able to understand it. So this is a function, and its name is getDays. And a for loop is something that we have been using from day one. So for math, so we define a variable math, and we are using a member operator in that whatever month that is contained in a month, in months, and I defined the months here. Okay, please proceed to use the get days just by passing on this function. You pass in the year, at the same time you pass in the number of months, and then your output file is going to be Uganda climate, the year and the month. And then I define, so this line of code is just redirecting us that everything is going on well, and I'm downloading your files. This is this line. And then here, I'm able to define a dictionary, which is reanalysis ER5 single level datasets. And I have the key values and the value themselves. The way it is, and the time steps I'm getting from this up to 18. The area, these are boundaries for Uganda. You can change it each other way that you want. So in this case, I'm able to download more than one parameter. Yes, you go through this. It is able to download for you the datasets. And in this case, for myself, I was redirecting this data to a dataset into the folder called data downloads. So here you redirect it the way you want it. So Israel, what are you trying to do? This is you, Israel, I think. Remove your things. Eh? So that's it. That's it to do with downloading. And after downloading the datasets, then we are going to look at them. From my experience, this is something that I experienced while working with datasets from ECMWF. The first one was I would download datasets assured that it is going to do a net CDF file. But in actual sense, because these datasets are heavy and computers will behave the way they want. So I ended up getting zipped files. So I wrote this script, that this script is able to check which type of file. Is it a net CDF file or it is a zipped file? So in this case, I tested these files after downloading them. I tested and I discovered that in actual sense, they are not direct net CDF files, but they have been downloaded while being zipped. Okay, so what I did was, this script is able to check which type of file that I have. If it is zipped, then it's going to bring me zipped true. So in this case, true, it is a zipped file. So if it is a zipped file, I went ahead to extract them. We know file extract. So I went into my download folder. I read the files that are downloaded, and then I unzipped them. And after unzipping, then I got the .cdf files, and it was not one file, there are two files, which I was able to read on script 22. So script 22 connects and reads these netcdf files after being unzipped. And after unzipping, then I'm able to print out and get to understand the data sets that I have, their structures and whatsoever. But remember, we did look at pandas. And if you can remember pandas, who can remember pandas library? Who can say who can say one sentence about the pandas library before I can explain this script 30? Who can say line about the pandas library and why we need it? Who can say line? Just one sentence, if really we have been practicing.
I think pandas helps us work with tabular kind of data.
Yes, so we are able to look at this data in a tabular form. As we can see up, this is Quagmire. When you first look at it, then you need to stretch your eyes and say, what is this? But once I convert this data, so what I have on this line, I have the first data sets being with DFA1, then the second data sets being DFA2. And then I'm able to use pandas to merge D1 and D2, and I'm imaging it over the common variables that are common. In this case, the valid time, the latitude, and the longitude. And then I have my imaged files. That is DF3. It is combining both. So when you interface with this script, you realize that while downloading these datasets, the system wouldn't image all the parameters at once. Remember, I selected more than one parameter. So I had to bring it together using merge, and merge is a function within the pandas library. So I have my DF3, and it is taking over this shape. So next is going to have this into the map. All I need to do is to go through this script. These are some of the things that we have been looking at, and I don't think that I need to labor myself so much on this, that I'm going to go into the def3, get the validity type, and in this case, I'm only getting the data for first. You go through this script. These are things, the normal way of drawing graphs is what is from here up to down. And ultimately on the first, you would have this kind of graph on the first. You would look at this and you get to see the total precipitation. So the first graph, I've only extracted one parameter, and the line that is extracting, that is TP. So you make sure that this name, the TP, the way it is here, it is the same way that it is appearing here within your data sets. So second, I tried to plot the surface pressure. Of course, I get the validity time the same way. I get the latitude, longitude, and the surface pressure, the way it is in my data set, it is SP. It is SP somewhere. SP is here. So I get the surface pressure. And you know how to use these things. You are the experts in this. So this is surface pressure. And then the temperature distribution on the first, how was it as far as ER5 datasets are concerned, so this is the script, it is the same. I go into the DF file, I get the validity time. I'm only interested in the first. And then the graph is the same. I pass it over the temperature, which is the T2M. This is the variable that I'm capturing. And this is the kind of map that I have. And next is I wanted to plot the contour lines. In this case, to plot them, I selected the surface pressure over the same validity time. What you need to note, this is just for demonstration purposes, but when you get to learn, you can develop a lot of products from this. As I'll be sharing, it may not be today, but on another note, you can generate very, very, very good product. The way of drawing this map is the same. You pass it over the latitude, the longitude, and the kind of parameters that you have. But of course, you should have some of these libraries, okay? Some of these libraries, and we learned how to install libraries, and we have something of this nature. So you have surface pressure plotted, and for people who understand synoptic meteorology very well, this would be the basis for you to really compare this with our observation data sets, and you get to understand which kind of systems are active, which kind of systems are developing over our country. So I put this together. I wanted to have some bit of convective accumulation precipitation into the map. And in this case, this is contained within the CP. The CP is part of the data sets that we have, the convective precipitation. And mature, and this is what I was able to get, that it was showing me some bit of convective precipitation as of the September 1st. All right. So do you have any questions as far as this kind of work is concerned? Is somebody would have some bit of a supplement? If there is anything that you wish that I've not shared, anything that you wish that I've not put well, you are the expert in this. Some of our colleagues I think in data, they have been doing this kind of work for a long time. They are more experts in this than I do. They will be able to come in and chip in a word in and there. All right, the floor is back to you, colleagues, for your questions, for your supplements. Thank you. Colleagues, the floor is yours for your questions, for your supplements, if there is any. No questions? At least you can come and say one word or two.
Hopefully. Yeah, thank you, Jose. I really like this initiative. It's really good. But I would be interested in a way of validating some of these products. Now, like when you look at this surface pressure, when you look at the values, do we expect such values beside when we try to use our observations? If you could go back to the rainfall, if you could scroll up a little bit. Yeah, when you look at this total precipitation, when you look at 0.0020, I would be interested in what is its implication. When you look at the blue stripes, what does it really mean? Is it that's not resolution, David. Is it something like that? Do you need to multiply it with something to boost it? So we need something to validate a product like this. It would be pretty good if we downloaded Era 5 alongside Chaps, but Chaps is not ready by now. Maybe we try with August. If you tried with August, we put total precipitation of Era 5 and then total precipitation of maybe Chaps or CRU. It would give a better picture. And then it is good that we have the August data. We would still look at the August data. Then going forward, I don't know if administration could allow us to have a glimpse of the house data set. We'd also use it to validate some of these products. But I'd really appreciate, and I don't know if people could allow giving you a hand clap. They would really clap for you. Thank you.
Clap in the chat.
It's all right. I like those kind of discussions. Benon, what you have here is for classroom environment. It is not for operations. But of course, we know that when we get into operations, things do change. We need to play around with figures in and there. Okay? But the most important thing from my end was to introduce to those people that have never downloaded that actually even don't know whether ER5 script datasets do exist, the CHAPS datasets do exist, and how do we interpret. When we get into operations, things can be a little bit different because you are looking at generating a product that we are going to use in our daily operations. Yeah, thank you so much for that. Yeah. So the most important thing is this is for classroom environment. It is an eye-opener for us who have not yet started to understand that these things do exist, and then we start using them. Yes, other people, please don't keep quiet. We are colleagues. Nobody is an expert in this. Nobody. We all learn from each other every now and then. From what I've presented, you can say a word like Benon has had something to supplement it, then we can begin from there. Last time we looked at observation data sets, and this time around, we have progressed into how we can download data sets. To some people, they would just hear this as a story that how do we get into download these data sets? Even myself, the first attempt, I wouldn't understand how can I get a few parameters? How can I tweak? How can I get a strict script to only get me the data sets that I want? Okay, and from there, then we can go into the direction that Kalena is pointing at, to how do we add meaning into these data sets? Do they agree with observation data sets? Okay, so you have a challenge of data assimilation. How do we assimilate the two data sets? So that we make meaning out of them. Are we together? Can we hear from Chisila David? Chisila David, don't keep quiet. You have interfaced with this more than any other person. People in DADIX, the former DADIX. People like David, people in forecasting, you are interfacing with the products, I don't know, from the Synergy system, from other ECMWF, but those ones are not customized for Uganda. You just get them on a large scale, like that map that you are using for South Africa. I think they generate it where you are able to track those synoptic features that do develop and they influence our weather. So how do we get them into getting the local systems that would that would influence our weather locally? So I'm waiting for another participant to say a word or two. And in case we have people who are ready for presentations, still you can let me know. But for my case, as far as today's class is concerned, that's what I'd prepared. But the floor is open for discussion. Discussions are very important. Reason being, we get to learn from one another. Yes, the discussion is open. Forecasting office. Would this be useful to you? This is surface pressure. This is surface pressure. This is convective precipitation. Would this something that would be useful to you? So as people get ideas, so I'm waiting for people to log in, to unmute themselves. And you say one word or two. Even you can tell us your confusion. Have I confused you more? As far as this presentation is concerned, let's not keep quiet, colleagues. So the floor is open for discussion.
Good morning. This is Mercy. So for me, my confusion is understanding these outputs that we put out. Like if you're given this output and told like explain it without like maybe looking at whatever commands you've been using. Like, would you be able to? Because for me, sometimes I like when I produce something, I'm even asking myself, is this really correct? So that's my confusion.
So the confusion is how to interpret the products, okay? Yes, so we had prepared, we have experienced people here who can interpret this, people in forecasting. And I don't want to go into explanation on how to interpret the things, but I'd invited Dr. Joanne. She's going to, I think next week we shall have her. She's going to make a presentation on how to interpret synoptic, these NWP products. For example, given this, I can remember a few things here. How do we derive knowledge out of it? Okay? In order to understand the high pressure systems, the low pressure system, the cold front, the warm front, the trough, those things, that is synoptic meteorology. But you have forecasters here. Somebody can come in and chip a word or two. People in forecasting and tell me. I don't know who was logged in today from NMC, but clearly people can interpret this. If you have this kind of distribution, what does it mean? Okay, what does it mean? if you have something of this nature, the way Benon was putting it, how do we make it more better? Right, a minute. Okay, I'm back. I was saying the discussion is open. Let's say one word or two. For Marcel's case, your issue is going to be handled. You said somebody is going to come and make a presentation on on which kind of NWP products that we can look at, what are those things. Yeah, so that when we generate a product, then we can add the knowledge out of it, because this is something that is very important. So any other suggestion? Can I hear from Mike? I'm going to point at people. William Maisha is experienced, one of the most experienced people here. You can chip in a word or two, sir.
Thank you, Mr. Balifu Dembe. The maps are clear, and if you have ever done synoptic, it can give some prediction and
So, Mike, are you still with us? Okay, colleagues. So can you say that that's we don't have any other input? So do you have people that we are ready for presentation today, as far as last week's work is concerned? Yes. So do you have colleagues that we are ready to present today? We still have some time. We would have those presentations. And my prayer is, you see, when when we don't show any means of progress, really you wonder what to do next. Okay. So okay. So can we have one person to come and give us the closing water? You have to wait and see these things are over. Then we can commit what we are going to do next. I think next week we shall endeavor to have a presentation on interpretation of different medical ways of teaching models. Because we have interpreted somehow, so we are only left with as practice, which we are going to continue what they do it. So somebody forecasting office, you are there. You can say a word called to close. Someone in the first stages all right, you don't have anything to say. Let's say this is here. So thank you so much for the time. We meet again next week on Thursday, but I would encourage you to continuously review the previous classes, continuously get on, start looking at the script. When you get a script, there are things that you're supposed to look at, whether and variables. First of all, check which kind of libraries that have been imported, which kind of variables that have been declared, which kind of data structures that are being used, lists, dictionary, and then post statement, the world state that are being used. Once you are able to identify those things, then look what does the script running. Is it running successfully? What are some of the things that I can change on this script to improve its output? That way. Is it getting data for the first check in the data set? If it is only first, other data sets do exist? If the answer is yes, you try to pass on data for second and see how is second. Okay, still go back to the data set and check. Do you still have for third, fourth? Keeps on changing. Ask yourself, can I calculate the monthly totals? If the answer is yes, how can I get the monthly total? If this data is for others, and I have my observation data set. For example, that the pattern for July, and you have downloaded data for July. How are you able to check and assimilate how these data sets agree with one another? So if you see this, you are going to be learning, okay, how learning Python language, but also learning how to apply it in data science, which is your daily routine. So, right, colleagues, in case you don't have any question, I beg to stop this class here. Have a good day. The discussions can continue on WhatsApp in case you have any questions. In case you get challenges, download the script. In case you get challenges, running the scripts, you have our colleagues here who can guide you in and there. Thank you so much and have a good day.